So we've been looking about how to form cations and how to form anions, and the fact that we can add those together. So when we looked at lithium, we said we had lithium gives up an electron, becomes lithium plus 1, and then it has the electron that it gives up. And bromine can actually take that electron that this guy gave up and form the bromide ion. Okay? And then we can add those together. Remember, the arrow is like an equal sign in algebra. We have something on this side, something on that side, they cancel out. We add up everything on this side. Lithium plus Br, lithium plus Br minus. Now, this means that we have one lithium and one Br. Now, we said that when we have these things, ions form ionic compounds. They're attracted to each other and they form these ionic compounds. The key about ionic compounds is that the overall charge is 0. So the pluses plus the minuses has to equal 0. Okay? So this tells us that we've got one lithium and one bromide, and that makes the ionic compound. Now when we write the ionic compound, we can't show any charge. Okay? When you write ionic compounds, there will be no charge. So we can't write the plus, we can't write the negative. We only write how many of each thing we've got. So we've got lithium, there's one of those, and bromide, there's one of those, and so this is lithium bromide. Okay? Now it's fairly straightforward when your charges are the same on both your positive and negative guy. Let's look at what happens when they're not the same. Okay? Let's go back to barium. I've got that written up here already. So with barium forms a +2 charge because it gives up 2 electrons. If we have a negative ion of iodide, iodine only accepts 1 electron to form iodide. So this guy is giving up 2, but this guy's only taking in 1. What happens to the other guy? It doesn't just float away. We have to account for it. So we need the second equation to actually have 2 electrons in it. And how we're going to do that is we're going to take this entire equation and multiply it by 2. Okay? Now this is just like math. We use the distributive property. We end up with 2 electrons, 2 of the iodines, and 2 of the iodides. So let's rewrite that. When we have 2 of something, we write it as a coefficient. We write it in front. So here we've got 2 electrons, we've got 2 iodines, and 2 iodide ions. Now this guy gave up 2, and this guy accepted 2. All the electrons are accounted for. So now we can go ahead and add these up. We couldn't add them up over here, but we can over here. 2 electrons here, 2 electrons there, they cancel out. So let's go and finish adding this guy. We've got a Ba over here, but we have 2 of the I's. And over here we've got Ba plus 2, and we've got 2 of the I minuses. Okay. So now we've got these guys, and these guys come together to make an ionic compound. Okay. So when we write an ionic compound, the number that follows the particular thing tells us how many there are. We use subscripts, right? So this here is a coefficient telling us how many of the ions there are. But in the ionic compound, we're going to write a chemical formula, and they're going to be subscripts. So we only have one Ba, so the subscript would be 1. Remember, if it's a 1, we don't write it. We have 2 I's, 2 I minuses technically. So we've got I, and we've got to put a 2 there. Okay? And we can double check ourselves because then we know that the whole thing has to equal 0. So we've got 2 pluses, because we've got 1 plus 2, that's plus 2. And we've got 2 of the negative 1's, which is minus 2. So the whole thing is 0. Okay? So we can always double check our chemical formula with making sure that we've got an overall charge matching the overall charge of this particular thing. This particular thing is an ionic compound and has a 0 charge. Now there's a shortcut to doing this, and that is, we can take the barium plus 2, we can write out our ions, and the I minus. And if we don't want to go through this whole thing, what we can do is this shortcut. We take the number that's up here, we're not taking the charge, we're just going to transfer the number, and bring it down as a subscript there. We take the number here, which remember is a 1, because it's negative 1. And that's the subscript over here. So when we write this with our shortcut, it comes out to be barium with a subscript of a 1, which we don't write, and iodide with a subscript of the 2. So you can see whether we did it this way or this way, we got the same answer. This just takes a whole lot more work, right? So the shortcut comes in very, very handy. So we're going to look at that. Let's try another one with this shortcut. Okay? Let's do aluminum and sulfur. Okay? Aluminum, we know from our periodic table, look at its position, it's in the 3A column, it's got a +3 charge. Sulfur is in the 6A column, it needs 2 more electrons to get up to the octet, noble gas conformation, and so it's got a -2 charge. Let's go ahead and do that shortcut. The 3 comes down as a subscript there. The 2 goes as a subscript over there. And so the ionic compound has aluminum 2, S3. Okay. Remember, we can always double check the charge. We have 2 of the +3s. So how many pluses is that? Well, that's +6. We've got 3 of the -2s. How many minuses is that? -6. +6 -6, we got 0. So we know we're on the right track with that chemical formula. Okay. So this takes when we have single atoms as our ions. But what if we don't have single atoms as our ions? Suppose we have a polyatomic, for instance. If we have a polyatomic, well, we need to know how to deal with those. So we're going to go ahead and get some practice at dealing with those. Basically, they're going to be just like the ones we just did. We just have to take that polyatomic and think of it as a whole. And doesn't separate into its individual atoms that make it up. It's just treated as a whole big clump. Okay. So let's look at sodium. Sodium has a +1 charge. It's in 1A column. And let's look at hydrogen carbonate. Hydrogen carbonate is HCO3, and it's got a -1 charge. Well, remember, the 1 here goes down there, the 1 there goes over there. So we're going to end up with sodium subscript 1, HCO3 subscript 1. Okay, but that subscript applies to the whole thing, not just the O's, not just to the C's, not just to the H's, but to the whole thing. Alright, let's try another one. Here we're going to have something that has more than just 1 for a charge. Potassium has a +1 charge. Let's try phosphate for the negative guy. Phosphate has a -3 charge. So I'm not going to draw the arrows this time. The 3 comes down as a subscript here. The 1 is a subscript over there. So we end up with K. There are 3 of them. But the PO4, there's only 1. As long as there's only 1 of them, we just write the PO4. Now, if there's any other subscript other than a 1, we have to actually put parentheses around the polyatomic. Let's look at an example of doing that. Let's look at aluminum. Aluminum we know has a charge of +3. Let's look at sulfate. Sulfate is SO4, and it's at a -2 charge. So the 2 comes down here, the 3 comes down there. Okay, let's do the 2 first. Aluminum, subscript 2. Now the SO4 gets a 3 subscript. Because it's a 3 of the whole thing, we need to put parentheses around the SO4. And then the 3 as a subscript. Tells us there are 3 of those whole things, the whole polyatomic. Okay. So use those parentheses whenever that subscript is something other than a 1. We've done all of these with the single atom as your positive guy. Let's use a polyatomic as a positive guy. and our cation here is ammonium. It's the only polyatomic positive one that is on our list of ones that we have to know. And let's look at HPO4, and that guy has a -2 charge. So the 1 comes down here, the 2 comes down there. Okay. Remember, this is a polyatomic, so it's 2 of the whole thing. So we've got to write the ammonium with a subscript of a 2, and the HPO4 has a subscript of a 1. Now, if it helps you to write the parentheses there, when there's only one, go ahead. I'm not going to take off for it. But technically, we don't need those parentheses. It's just one more thing to write. The subscript is a 1. We should recognize this as a polyatomic because we have a list of polyatomics that we have to know and memorize. Now, there's one more thing that we need to address here, and that is the fact that, well, we've got these ionic compounds. And ionic compounds, we only have to always have the lowest ratio possible. So let's look at an example when we don't have the lowest ratio possible. So far, we've lucked out and only dealt with ones that have lowest ratio possible. Let's look at tin. Tin, remember, can have more than one charge. It is the transition metal. It can be a +2 or a +4. We're going to do +4 right now. We can also look at oxygen, which has a -2 charge. So let's go ahead and do this guy just the way we did before. I'm going to draw in our shortcut one last time here. Make sure we've got it down. The Sn ends up with a subscript of a 2. The oxygen ends up with a subscript of a 4. But the rule with ionic compounds is we need the lowest ratio possible there. Well, we can divide both of these numbers by a 2. So then this becomes SN1, remember we don't write the 1s, O2. So if we were looking at tin 4 oxide, this is the chemical formula for tin 4 oxide. It is not this one, okay? So always do the shortcut, but in the back of your mind, always check to make sure that those are lowest ratio possible, okay? Alright, so there's a number of these in your homework that you can practice, and we'll make sure that you get a lot of practice at writing these chemical formulas for ionic compounds.